competitive programming. This course is offered by Professor Neeldhara Mishra, and I am one of the TAs for this course. I am Nikita Yadav. I am a PhD student in the Department of Computer Science and Automation, IISc Bangalore, and I will be taking live class every week on Friday 6 pm to 7 pm starting 29th July. The Google Meet link for the live class has already been shared with you all on the course page, and the recording of the lecture will be posted on this YouTube channel every week after the live session. The agenda for today's video is to look at how to solve a programming problem on a coding platform like Codechef, and second, we will discuss a few week zero practice problem. So let's solve a problem on Codechef. So first of all, Google Codechef and you will open the codechef.com website. There log in or register yourself, and then on the home page you will be able to see the events and contests which are upcoming. Then you can go to the practice menu, and there you will be able to find a lot of practice problems which are categorized by different topics. For example, basic programming, arrays, strings, math, sorting, etc. So here in today's session, I am going to pick a very simple basic programming problem because the motive is only to introduce you to the platform. So here I have chosen the basic programming topic, and all the problems are sorted in terms of difficulty level. So let's pick one problem. So I have picked the problem chef bottle, which is chef and water bottles. So this problem is already open in my browser. So here every problem you'll be able to see that it has a statement tab where you will be given the problem statement, input format, output format, constraints, and some sample test cases along with the explanation for it. On the right hand side you have the IDE where you can choose the language for your implementation, and you can then, once you have implemented it, then you can click on compile and run to compile the program, and it will be run against the sample test cases. Then if you are getting correct answer for the sample test cases and you are sure about your implementation and solution, you can click on submit code, and the code will be submitted and it will be run on extra test cases which are usually hidden. And you can check all your submission history on the submissions tab, and then you can go to the solution tab to check for the solution, and you can ask your doubts in the ask a doubt tab. Now let's look at the problem statement. The problem statement is that the chef has n empty bottles where each bottle has a capacity of x liters. There is a water tank in chef land having k liters of water, and chef wants to fill the empty bottles using the water in the tank. Now assuming that chef does not spill any water while filling the bottles, find out the maximum number of bottles chef can fill completely. So the problem is very simple. You are given a tank of water and you have bottles, and you are given the capacity of each bottle, and all you have to do is tell that how many bottles can be filled with the given capacity of the tank. So the input format says that the first line will contain t, which is the number of test cases, and the second line will for its, and then there are each test case will contain 3 inputs integers, which is n, x, and k, right? And then the output format for each test case is a single integer value which will tell the maximum number of bottles chef can fill completely. It is important to look at the constraints of the problem because most of the time write code uh, you want to write code such that the time complexity of the code is not very large. Otherwise, if the constraints are high and the time complexity is also not good, not optimized, then you will most likely get a TLE error, which is time limit exceeded error. So here the problem is very simple and the constraints does not matter because the solution to the problem is uh, order of one time complexity. It's just a division operation and therefore the constraints are not so important here. Now let's look at the sample test case. Sample test case, the input contains, first line of the input has value 3, which shows the number of test cases. Then there are 3 lines, one for each test case, and each line contains 3 inputs. So the first input on each line is the number of empty bottles. Second is the capacity of each bottle, and third is the capacity of the water tank. So for the first test case, uh, we can see that the capacity of the tank is 8 and the capacity of the bottle is 2, so we can fill 4 water bottles, and therefore our output is 4. For this next one, the capacity of the tank is 4, which is less than the capacity of the bottle, so we cannot fill any bottle completely, and therefore the output is 0. And then for the third test case, we have the tank capacity is 4 and the bottle capacity is 1, so we can fill 4 bottles completely, but the number of bottles that we have is only 3, so that means we can fill only 3 water bottles, and therefore the output is 3. So now let's code this and see. So first of all, we need to specify the variable for the number of test cases, which is, I'm going to specify as int t, and then after that you would also want to specify the variables for other inputs, which are integer n, x, and k. Then you will read the input test cases, and then for every test case you will read the variables n, x, and k. After that, we want to find the number of bottles, maximum number of bottles which can be filled completely. So let's define a variable m, which is the maximum number of bottles chef can fill completely, right? So m is equal to k divided by x. Now here we can directly print m whenever m is less than equal to n, but if m is greater than n, then we will print n. So we will just need one if condition that whenever m is less than equal to n, then we will just print m, otherwise we will print n. And that's the solution. So let's now try to compile and run it. So as you can see, the status is successfully executed, and so that means that the test cases were passed on the sample test cases. And now let's submit the code. So we got the status as correct answer, and it was able to pass all the test cases. If you do not like the IDE, here you can also write your code in some other IDE that you prefer, and you can then upload the code as a file here. Okay, now moving on to the next component of this video, which is to solve the week 0 practice problems. So week 0 practice problem is there on the website you can find, and this assignment is only for practice and it will not be graded, but this is a very good sanity check for you all to test yourself that whether you are prepared to take this course or not. It is this checks only your knowledge of data structures and algorithm, which is supposed to be a prerequisite for this course. And if you have taken this course, taken the data structures and algorithms course a while back ago, then it is advised that you revise the concepts and then do the problems. This week 0 assignment should not be very challenging for you. It is okay if you do not remember everything, but you should be able to understand the problem and solve the problems. So we are not going to solve all the problems from this assignment. We are going to only take few problems, and if you have any doubt in the problems which we are not going to discuss in this video, then please feel free to post your queries on the Discord channel. So let's look at problem 1, which says that how many ones does the following procedure print when run with input n? So this is a recursive procedure because this procedure calls itself. Now we want to find that how many times the print1 statement executes. So the print1 statement is actually is in the base case. So it will be on the leaf nodes of the recursive tree. So let's draw the recursive tree for this procedure and count the number of leaf nodes. So the level 0 will have only one node, which is ones of n, and then ones of n calls ones of n minus 1 in a for loop which goes from 1 to 2 power n. So that means that level 1 has 2 to power n nodes. Now each node in level 1 calls more procedures with the argument n minus 2. And how many of them? So actually it calls 1, so it calls 2 to power n minus 1 functions. And then we are interested in finding out that how many leaf nodes are there in this tree. So let's do the calculation. So level 0 has only one node. Level 0 has only one node. Level 1, so there is a mistake here, it should be level 1. So level 1 has 2 to power n nodes, and level 2 has 2 to power n into 2 to power n minus 1 nodes, because for every node in level 1 it is going to call 2 to power n minus 1 functions. So therefore we have 2 to power n multiplied by 2 to power n minus 1 function calls, that is this many number of nodes. So we have to just do continue this calculation till the last level, which is level n. And on the level n we will have, if we continue the same calculation, we will get the number of nodes as 2 to power n multiplied by 2 to power n minus 1 multiplied by 2 to power n minus 2 and so on multiplied by 2 to power 1, which is equal to 2 to power n plus n minus 1 plus n minus 2 and so on, which is equal to 2 to power n into n plus 1 divided by 2. Now let's look at the problem 2, which says that how many connected components result after performing the following sequence of union operations on a set of 10 items. So we are given a set of 10 items and we want to find out that how many connected components are there. So let's do this step by step. So this is the input, and initially we have let's follow the input. Initially we have 1 and 2 are in the same component, then 3 and 4 in the same component, where the component is denoted by these rectangles, and 5 and 6 in the same component, and 7 and 8 in the same component. Then when we are performing the union operation with 7 and of 7 with 9, then we are going to find this component in which 7 belongs, which is 7 and 8, which is the last rectangle, and we are going to add 9 to that component because 9 currently does not exist in any of the other components. After that we have 2 and 8, so we want to make union of the sets which contain 2 and 8, which is the set 1 and set 4. So set 1 has 1, 2 and set 4 has 7, 8 and 9. So let's do the union of these sets, and that results in this. Now we are left with only 3 sets. Set 1 has elements 1, 2, 7, 8, 9. The next input is that union of 0 and 5. So 0 does not already exist in any of the sets, and 5 is there in the third set. So we are going to add element 0 to the third set, and that gives us this 5, 6, 0. Now the last operation says that take the union of 1 and 9. So 1 and 9 are already part of the same set, which is the set 1, and therefore we do not need to do anything here. So after processing this input, we get 3 connected components or 3 sets, and then therefore the answer is 3. So now let's look at problem number 3, which asks how many bit strings, that is sequences over 0 and 1 of length 18, have no consecutive ones. So we want to find the number of strings which does not have consecutive ones. Now let's look at the solution of this problem. So let's do this. Let's try to solve this from length 1. So for length 1, we have only 2 strings possible, which is 0 and 1. And both of them satisfy the condition that there should not be any consecutive ones. Now for length 2, the number of strings which are possible is 4, but one of the strings, which is 1, 1, does not satisfy the condition, so we are left with only 3 strings. For length 3, we have 5 strings, which is 0, 0, 0, 0, 0, 1, 0, 1, 0, 1, 0, 0, and 1, 0, 1. For length 4, we have 8 strings. Now let's try to observe the pattern here. So we can observe that when we are creating strings of length 3, then let's go back to length 2. So in length 2, the first string is 0, 0. So when we have 0, 0, we can append 0 or 1 at the end of 0, 0. Both are allowed. But if we have any string ending in 1, like 0, 1, then we can append only 0 at the end of the string and not 1, because appending 1 will violate the condition. Therefore, we can derive all these strings of length 3 from the strings of length 2. Let's see how. So 0, 0 is the first string. We can append 0, we get 0, 0, 0. Then we append 1, we get 0, 0, 1. When we have 0, 1, we will append 0, we get 0, 1, 0. And then we cannot append 1. Then when we have 1, 0 string, we will append 0, we get 1, 0, 0. And similarly, we can append 1, 0, 1. So that's how we get strings of length 3 from strings of length 2. And we can follow the same for length 4. Let's see. So for the first string, which is 0, 0, 0, we can append both 0 and 1. That results in the first two strings. Then for the next string, 0, 0, 1, we can append only 0. So we get the third string. For string 3, we have 0, 1, 0. Again, we can append both 0 and 1. So we get 0, 1, 0, 0, 0, 1, 0, 1. And for the fourth string, 1, 0, 0, we can append 0 and 1 both, resulting in these two strings. And for the last one, we can append only 0, resulting in the last string. So we can do the same. And so let's now denote all the strings which are ending in 0 with P, and denote the strings ending in 1 with Q. Then P of I, where I is the length of the string, is equal to P of I minus 1, which is all the strings of length I minus 1 ending in 0 plus all the strings of length I minus 1 ending in 1. That will give us the number of strings of length I ending in 0. Similarly, for all the strings of length I ending in 1 is actually equal to only the strings of length I minus 1 which ended in 0, because only then we are allowed to append 1. If it ended in 1, then we cannot append 1. Then we can count the number of strings of length I which satisfy the condition as P of I plus Q of I. Now using this formula here, we get P equal to 1, here Q equal to 1 and C equal to 2. Here we can get P equal to P of 1 plus P of Q, P of 1 plus Q of 1, which is 2, and Q of 2 is equal to P of 1, which is 1, and C equal to 3. Then P of 3 is equal to P of 2 plus Q of 2, which is 3, and Q of 3 is equal to P of 2, which is 2, and the count is equal to 5, and so on. Now observe that the count is actually a Fibonacci series. The count for length 1 is 2, for length 2 is 3, for length 3 it's 5, for length 4 it's 8, and so on. So you can then calculate the count for length 18 by computing the Fibonacci number. And I leave that as an exercise for you. You can either use the calculator or write a program for it and compute the value. And the answer is 6765. Now let's look at next problem, which is problem number 8. So problem says that suppose you have a set of n people who all do not know each other, and you have to process a sequence of queries of the following kinds. The first query type is make friends. given two numbers x and y, then x and y become friend with each other. And the type 2 query is are friends x comma y, which outputs 1 if x and y are friends and outputs 0 otherwise. So in particular, for every pair of people, we need to maintain a state indicating whether they are friends or not, and update this state based on the queries of type 1 and report the state of the queries for type 2. Since you have learned about the disjoint sets data structures in your algorithms course, you decide to store the set of n people as n singleton sets to begin with. For each query of type 1, you perform a union operation, and for each query of type 2, you perform a find operation. So what can you say about this algorithm? So let's take a input and try to do a run of this algorithm which is suggested here. That is, for each type query of type 1, we will perform a union operation, and for each query of type 2, we will perform a find operation. So let's look at the solution for this. So here I have taken the input as this, that the input is that MF denotes make friends and AF denotes are friends. So first is type 1 query, which is make friends 1 comma 2. So we have here we draw a line between 1 and 2 and which shows that they are friends. Then second is make friends 3 comma 4. Similarly, we draw a line between 3 or 4 showing that they are friends or in the same set. And then make friends 2 comma 3, which is to make 2 and 3 as friends. So we draw a line between 2 and 3. Because our operation is a union operation, so we are going to make union of set 1 comma 2 and set 3 comma 4, and now all of these elements are in the same set, which is all the elements 1, 2, 3, 4 are in part of the same set. Now if we are asked are friends 1 comma 4, then we will perform a find operation, and if we find that both the elements are of the same set, then we say yes, they are friends. So here we will find 1 and 4 in the same set, and our algorithm will say yes, they are friends. But actually they are not friends, because there was no query of type 1 which said that make friends 1 comma 4. So therefore this algorithm will not produce an accurate result. Now let's look at problem number 12, which says that suppose we have a simple undirected connected graph G where all edges have no negative weights, and in fact the weight of each edge is either 1 or 20. Now consider the following subgraph H of G. The vertex set of H is same as the vertex set of G, and the edge set of H consists of all edges from G whose weight is 1. Suppose H has 3 connected components with 10, 15 and 30 vertices, then the weight of any minimum spanning tree of G is. So we can denote this problem in this manner. Let's denote the subgraph H with these ovals, where the first oval is the first connected component with vertices, number of vertices 10, and the second oval is the second connected component in H with the number of vertices as 15, and similarly the third oval is the third connected component with number of vertices as 30. Now in order to create the minimum spanning tree, we want to minimize the weight of the edges, and so therefore we want to pick all the edges which has weight 1 first, and that is our subgraph H will be used here. So we will take the first connected component which has vertices 10, and we will pick any 9 edges from it, because all of the edges are of weight 1, so we can pick any 9 edges, and then we will take the second component and we'll pick 14 edges, and then we'll take the third component, pick 29 edges. Now we have 3 components which are not connected with each other, so we need 2 edges to connect these components, and therefore we put 2 edges. And we know that all the edges which are not part of H have weight 20, so these edges are of weight 20. So the weight of any minimum spanning tree is 9 plus 20 plus 14 plus 20 plus 29, which is 82. So that is all for this video, and thank you for watching. Please post your questions in week 0 Discord channel. For any